So today we're going to go over the helix command in a part file. We use the helix command in engineering for creating flights for screw augers, so you'll hear me refer to it today as helix or flights, one or the other. So if you open up your part file, and we'll start with the material. So we typically use mild steel or stainless steel grade 3 or 4 for flights. Today we will go stainless steel 3 or 4, and if we hit the line command, go Control and R for the right view, pick up on your plane and click F3, find your endpoint. Now this will be your axis length line, so this will determine the length of your helix or your flights. So we're going to use 2.5 meters, so 2,500 millimeters, and accept that. Now we go to the measurement and raise this. You click on your line command again, find your endpoint, click on it, and press the S key on your keyboard. You will get a symmetric line from the endpoint. So this will be a reference line purely for the shaft diameter. So the shaft diameter, or the inside diameter of your helix, will be 200 mil. And press enter, and enter at 90 degrees, and we'll just move this out a little bit so we can see it. Just lift this one up a bit more. So if we go rectangle by 2 points, now you can use the line command for this. You have to make sure that this is a closed sketch, because this is going to be the actual flight or helix now. So if we find the endpoint of your 200 millimeter line, or your inside diameter, click on the endpoint, and we're going to make the helix or the flight 6 mil thick by 150 mil. Now this should give us a 500 mil diameter on the OD, on the outside diameter of the helix or flights. So this is all you have to do for your sketching. And if you go to your solids and you find your helix, you start with your closed sketch. So make sure you click on all 4 lines of your closed sketch. You don't use the reference line, but you do use the axis length line. So if you click on that and either right click or click on the accept button, it will preview your helix. So if you go to helix options, you have helix method, where you can use your axis length and pitch, axis length and turns, pitch and turns. I typically use length and pitch. You can have right-handed or left-handed flights, but I'm not aware of reason, or not so much the reason, but we typically use right-handed because it doesn't really matter with us when we're conveying material, because we'll change the direction of the motor depending on the flight hand. So you've got taper, which is by angle or by radius, and pitch, which is constant or variable. So we're going to stick with a constant pitch today, and we're going to make a pitch of 210 millimeters. And if we press OK, there you can see it. So I'm just going to right click on that, and there you have it. There are your flights or your helix. So this center inside diameter is where you put your shaft for welding the flights on. Now if you want to make some alterations, you can go protrusion, click on the helix, and we can change this to say 350 millimeters. Press the tab on the keyboard to get a preview. We can also go to this measurement, and this is why I lifted it up earlier, because you can go to 5,000, press the tab, and you can see a preview of it at 5,000 millimeters long. But we'll put it back to 2,500, and you can edit the profile, which will allow you to edit the profile of your flight. But we're happy with that. So one thing to note is that our profile sketch was to this line here, So you can see that it's all started to the right hand side of this line. So the thickness of the material has gone over. But when they manufacture flights, they're actually pressed from a sheet. So even though our axis length was 2.5 meters, let's just see if I can do this here. That will actually take you to this point. Yeah. So actually this length is 2,506 millimeters. So that's just because of the way that flights are manufactured. So you need to keep this in mind. If you wanted that dead 2.5 meters, it would be 2,400 and 2,900. And I've totally lost it. It is 2,494 millimeters. So yeah, just keep that in mind. I've already created a draft file off the part file earlier on. So if we just click on here, I'll update views and go principal. If we drag that over here, we can get our views. ISO view, which is for reference only. Just change the scale on this. Put that up in this corner, and we will shade with edges. I think it always looks nice when it's the ISO views coloured in when it's on a PDF. So yeah, if we, as I quickly showed you earlier, overall length is going to be 2,506. And that'll be 2.5. The OD should be 500mm, which it is, and the ID should be 200mm. So we'll just put some nice diameter symbols here, and there you have it. That's pretty much all there is to it, to be honest. Have a go, and leave a comment if you've got any questions, and I'll do my best to get back to you. Thanks.